section 4.2, solutions of systems of linear equations using the substitution method. So this is one of our first real techniques to solve systems of linear equations. The graphing technique that we went over in section 4.1 is not really a very practical technique. So let's look over the substitution method. Let me describe the substitution method while doing a problem. So on page 157, let me do problem number 4. So x equals 2 plus y. Let me call that r1. And let me call the second equation r2. 2x plus 3y equals 4. So the first thing to do is to solve one of the equations for one of the variables. So either equation r1 or r2 for either x or y. Well, if I look here, equation 1, I've already solved for x. So let's solve equation r1 for the variable x. That will certainly be easy. X is equal to 2 plus y. I'll call that solved equation S1. So now, let me use this solved equation S1 use the solved equation S1 to substitute. For the solved variable x into the other equation. So we used R1, so let's substitute into R2. So remember that once you have solved for your variable in some equation, then plug that variable into the other equation. And so, let me plug S1 into R2. And so, wherever I see an x, I replace x by 2 plus y. So now you notice that this equation now has, the equation R2, now has one less variable. And so, in this case, it only has one variable, so I can actually solve this equation for that variable, y in this case. So first let me multiply 2 inside the parentheses. So I get 4 plus 2y plus 3y equals 4. Let me subtract 4 from each side of my equation. And so 2y plus 3y is 5y equals 0. Let me divide both sides of my equation by 5. Actually, let me do this first. Let me add combine like terms. So 4 plus 5y equals 4. Now let me subtract 4 from both sides of my equation. So 5y equals 0. Let me divide both sides of my equation by 5. And so y is equal to 0. Let's call that S2. So now that I've solve for the variable y. Let me use that. So let's use this solve the variable s2, and let's plug into s1, and this will be to determine the other variable, in this case x. So let me do that. And so let me plug S2 into S1. And so I'll get, so S1 is X is equal to 2 plus Y. Well, Y is 0. 2 plus 0 is just 2. Therefore, I get that 2, 0 is a solution to my system of linear equations. Let me do problem number 30. So notice that this is a consistent system. This is the case of intersecting lines. Let me do problem number 30. So my first equation, I'll call it R1. 3y equals x minus 6. Second equation I'll call R2. X minus 3y is equal to 6. Okay, so let's solve for the variable x in the second equation. So let's solve for x in the second equation. So I have the second equation, x minus 3y equals 6. Let me add 3y to both sides of my equation. And so I have that x is equal to 3y plus 6. Let's call that S1. So now let's use S1 to substitute for the other variable, for the variable x in the equation R1, since we used R2 already. And so let's use S1 to substitute into R1. So wherever I see an X in R1, I will replace X by 3y plus 6. So we get 3y is equal to X, 3y plus 6 minus 6. The 6's cancel. So 3y equals 3y. Let me subtract 3y from both sides of my equation. And so I get 0 equals 0. So notice that in this case, I've eliminated all my variables. And notice that in this case, this is a true statement. Therefore, this is a case of a dependent system. And so, again, in exercises 1 through 30, solve the system of equations using the substitution method. So, this is the case of coincident lines. So in this case, there'll be an infinite number of solutions. Well, um, I actually have to solve it. Just saying there's an infinite number of solutions. Well, what infinite number of solutions? I mean, what solutions? Well, notice that it is all equations. So since 0 equals 0, that means that since these numbers are the same, that means that both equation 1 and equation 2 are the same equation. And that means that I can pick either equation. Let's say R2. So that means that any set of ordered pairs that solve this equation will be a solution to your system. Now, uh, it's better if I actually write this as a one parameter family of solutions. So let me do that. So let y be some variable. I'll call it t. You can call it any letter. I'll just call it t. So then from S1, I get that x equals 3y, but y is t, plus x. And so I get x equals 3t plus x. Therefore, the solution to my system can be written as, well, x is 3t plus x and y is t. And this is true for all values of t. So for all t, which are any real number. This is called a one parameter. In this case, the parameter is t, family of solutions. Let me do problem number 54. In exercises 31 through 65, solve the system of equations using the substitution method. Using the solution, identify whether the graph of the system consists of intersecting, parallel, or coincident lines. Okay, so let's call the first equation R1. 2x minus y minus 3.7 equals 0. The second equation, y minus 5x equals negative 11.2. So I can solve either the equations for either variable. But in this case, the easiest one would be to solve the second equation for the variable y, because there's a positive 1 as a coefficient of y. So let's use R2 to solve for y. So let's solve R2 for y. And so I have here R2. Let me add 5x to both sides of my equation. And so y is equal to 5x minus 11.2. Let me call that S1. And so let's use S1 to substitute for, in this case we solve for y, to substitute for y. in, well, for S1 we used R2, so I have to use the other equation, R1. And so let's substitute S1 into R1. So that gives me 2x minus y. Y is 5x minus 11.2 minus 3.7 equals 0. Okay, so I get 2x. Let me change all the signs inside the parentheses since there's a minus sign outside the parentheses. Minus 5x plus 11.2 minus 3.7 equals 0. Let me combine like terms. 2x minus 5x is negative 3x. 11.2 minus 3.7 is 7.5 equals 0. Let me subtract. Let me subtract 7.5 from both sides of my equation. And so I get negative 3x equals negative 7.5. Let me divide both sides of my equation by negative 3. So x is equal to negative divided by negative is positive 2.5. I guess I'll call that S2. Okay, so now let me use S2 to substitute into S1 to determine, to substitute x into S1 to determine y. So let me do that. There. So I'll take S2 and substitute it into S1. So I have y equals 5x 2.5 minus 11.2. So let me simplify that. And so y is equal to 5 times 2.5, 12.5, minus 11.2. So I get that y is equal to 1.3. And so the solution to my system is 2.5, 1.3. Since I'm able to solve for both x and y, these are intersecting lines. And so this is a consistent system. And so that really finishes off section 4.2. So do the following group works, and they'll be due on Sunday. So do Sunday. This will be September 18 at 9 p.m. So first, I guess, do group work. Well, let's say 3.4. And the password will be equations of lines, uh, all is one word, next to group work 3.5, and the password is inequality. And do group work 4.2. And the password is substitution. Okay.